Have you ever just stopped and wondered how a single piece of AI technology can do, well, pretty much everything? It honestly feels like magic, but it's not. There's this one fundamental principle, this secret superpower, that makes it all possible. So let's pull back the curtain and see what's really going on.
Okay, so think about this. It can take a sentence in one language and somehow find the exact corresponding pattern in a completely different one. It's translating meaning across cultures in the blink of an eye. And then there's this. You can give it a simple text prompt, like an astronaut riding a horse on the moon. And it creates a totally original, sometimes breathtaking piece of art. It's mapping our words to pixels. And if that wasn't enough, it can model the unbelievably complex dance of molecules to help scientists discover new, life-saving drugs. I mean, from language and art to biology. How?
So that really brings us to the big question, right? How can one type of algorithm be so incredibly versatile? What is its secret sauce that lets it tackle such a wildly diverse set of problems? Well, let's find out. It really all boils down to one single foundational concept. One big idea that unlocks all of this insane power. And the brains behind that big idea, that would be the neural network. This is the engine, the model inspired by our own brains that sits at the very heart of almost all modern AI. You know, at its core, a neural network is surprisingly straightforward. You've got an input layer, that's where the data goes in, like the pixels of an image. That data then gets chewed on and processed through one or more hidden layers. That's really the thinking part. And finally, an answer, like the word cat, pops out of the output layer. All the work is done by these little interconnected nodes called neurons, and the strength of their connections is controlled by what we call weights. Just think of them as thousands of tiny little dials that get tuned and retuned as the network learns.
So, with that basic picture in your head, we are ready for the big reveal. See, the secret to a neural network's power isn't what it already knows. It's about what it has the potential to learn.
And here it is. This is the secret. A neural network is what's called a universal function approximator. Now, that's a mouthful, I know, but the idea is actually breathtaking. It means that a neural network can, in theory, learn to copy or approximate almost any continuous pattern in the universe. From the physics of a bouncing ball to the subtle rules of grammar, it can learn the shape of that data. And get this isn't just some wild theory somebody came up with. It's a mathematical guarantee. It's called the Universal Approximation Theorem, and it was first proven way back in the 1980s. It formally says that even a pretty simple neural network has this incredible power. This theorem is the mathematical bedrock for basically all of modern AI.
Okay, so a mathematical guarantee is awesome, but how does it actually do it? Like, physically, how does it learn these incredibly complex real-world patterns? Well, the way it works is actually pretty clever. The whole key is understanding that the world is not a straight line. Simple models can only see straight line or linear relationships. Stuff like the more you study, the better your grade. But reality is messy. It's full of curves and twists and exceptions. It's nonlinear. So to model the real world, AI needs a way to create and follow these complicated, curvy patterns. And the secret ingredient that lets it do that is something called an activation function. Just think of it as a tiny little math rule inside every single neuron. Its only job is to take the straight line signal it gets and introduce a simple bend or a kink into it. It's just one tiny little piece of nonlinearity. So, one neuron by itself? Super simple. But then you add that little bend with the activation function. And then you combined thousands or millions of these simple bent outputs together. By layering all these tiny little bends, the network can build a shape of almost infinite complexity, perfectly molding itself to whatever the data looks like. It's exactly like using tiny, simple Lego bricks to build a massive, incredibly detailed castle. Simple parts, complex result. Now, I know this sounds like an absolute superpower, and in many ways it is.
But, and this is a really big but, the word universal does not mean perfect or easy. There are some really important real-world limits we have to talk about. For example, the original theorem said that one really wide layer of neurons was technically enough. But in practice, that is just wildly inefficient. It's why all modern AI uses deep networks. We stack multiple layers on top of each other. It's so much more effective because it lets the network learn a hierarchy of ideas. The first layer might learn simple things like edges. The next layer combines edges into shapes, and the layers after that combine shapes into things like faces or cats. And yeah, here's the fine print. The theorem guarantees a network can exist, but it gives us zero clues about how to find it. Actually training these things is really hard. You need mountains of good data. And there's this huge risk of something called overfitting, which is where the model just memorizes the answers instead of actually learning the pattern. It's an unbelievably powerful tool, but you've got to know how to use it right. So let's connect all this theory back to reality. Why does understanding this one core idea actually matter so much? Because it's the engine behind everything. When an AI looks at a picture and says, cat, it has successfully approximated the function that maps a bunch of pixels to the label cat. When a language model like ChatGPT writes a poem, it has approximated the function that maps a sequence of words to what we perceive as meaning. Every single major AI application is just a different flavor of this one core idea. And I think this quote just says it perfectly. Neural networks are not just algorithms. They are mathematical engines of approximation, capable of modeling the richness and complexity of the real world. So the secret's out. AI's incredible power comes from this basic ability to learn and mimic nearly any pattern it's shown, which, leaves us with the final and much bigger question. Now that we have a tool that can learn almost anything, what are the most important problems we should be pointing it at next?